Welcome to the ML Platform Podcast, brought to you by Neptune AI, the show where Piotr Niedźwiedź and Orimaz Grisiunas, together with top MLOps practitioners, explore the world of internal ML platforms and MLOps stack components. This is a special end-of-the-year episode focusing on LLMs and LLMOps, the state of MLOps, and what's next in 2024.
It will remain like that and gets more obvious how closely DevOps team needs to work with ML LLMOps team, if they won't be called the same.
Maybe it could be called a new area of MLOps that it's being created, so guardrails basically.
I think that with agent architecture, I think that we'll be exploring this a lot.
Because, for example, OpenAI in their press releases, not press releases, even conferences, they are kind of projecting AGI in 5 years or something, I think. Hello, everyone. This is a special episode of Machine Learning Platform Podcast. And in it, me together with Neptune's founder and CEO, Piotr Niedźwiedź, we will be talking about a review. Actually, we will be doing a review of 2023. We will talk about what happened in the MLOps market. We will touch upon some interesting topics when it comes to machine learning platforms specifically. Of course, we will not be avoiding large language model topic, and we will probably spend quite a lot of time talking about it. And of course, we'll finish up the episode with some of our predictions of what we expect to happen in this market in 2024. So hopefully it will be interesting for you, and super glad to see you here.
Piotr, you wrote the article MLOps is an extension of DevOps, not a fork, and then talked about it with Orimaz on MLOps Lit podcast later this year. What's your stance on it now?
My thoughts are quite ML thoughts, not binary. So it is not, I don't have a binary answer, yes, it happened or not. I think to some extent, this direction is still valid because we see that there are more people from traditional software development coming to ML space, or maybe I should say LLMOps space, basically are able to solve problems that before large language models were solvable using traditional ML or deep learning. So I see this movement that's today more engineers are involved in AI projects. At the same time, large language models and working with them on production, it is something that I'm not hearing very often about production, like really production, maybe use cases, yes, but really large language models being used in production, and as always, new capabilities, new algorithms, new techniques brings new challenges. So we have, in order to operate those models, we have even more requirements and things to solve than we used to have with more traditional ML deep learning models on production. So, but in an essence, what I want to, my article, my thesis was about the similarity between those two spaces, tech stacks, methodologies, and how important it is that they would work together. And I think it is very, very relevant today, where you need to make large language models very often are consumed through API. And it is something that very much has to work hand to hand with your traditional software where you're using it. So I think that these trends of those two fields are converging. Maybe it will be called differently, but getting closer is something we are going to see. What do you think, Orimaz, on that?
The backgrounds that I'm coming from, I do believe that most of the challenges that we were solving in machine learning when it comes to operationalizing all of the processes, we're kind of already very close to DevOps. So I always had this also thought in my mind that it is, we don't need to create a new paradigm specifically for it. It's more of an extension of DevOps, right? But we cannot kind of follow completely the DevOps principles because, of course, there's data involved. But it's mostly around training processes and not necessarily serving processes. So not deployment of the models. When it comes to deployment of the models, what I've seen, it was always just a pure DevOps practice, right? So it's not that different. It's almost always served via API, as I mentioned. So the deployment is no different, apart from the fact that you need to load some big binary into memory, and the results are non-deterministic, partially deterministic because it's still a very big kind of function underneath, but it's so big that we are having problems explaining it. But the patterns remain the same. You need to test it. You need to do maybe some blue-green deployments, maybe some canary releases, right? You can't avoid that. And the processes around it are the same.
I think
just
it
the
will
package
get
is different, right?
even more DevOps-ish to some extent, because with the new models, if, for instance, if you want to combine large language model with some outputs from specialized deep learning model, a very natural way to do is to use it as agent, for instance, of a large language model. And more agents you have, more dependencies, more versions to synchronize, and it is something that we are dealing in software space for years. So I think it is it will remain like that, and gets more obvious how closely DevOps team needs to work with ML LLMOps team, if they won't be called the same.
And actually, when it comes to, you mentioned agents, right? So all of these multi-agent systems where multiple LLMs are communicating between each other to produce final result. To me, it's like I'm also coming partially from DevOps and cloud engineering background. To me, it seems very similar to what service meshes are trying to do. So the communication patterns, right? So you have proxies between kind of applications. So in our case, applications are large language models, but you still need to be able to trace what is happening in between, how the requests are traveling, where the
smarter proxies. No, it's not
exactly. Right? They are black box applications, basically. Of course, then there is the data side of things that is not as DevOps-ish, right? So data itself is non-deterministic, but it's only kind of important when you're thinking about specifically monitoring machine learning models and in a specific way, not regular software practices related way, and training of models. But still, you can think about those processes. You can wrap all of those processes around regular monitoring practices. It's just what you do with the data that you receive is different, right?
I think that we'll see, like, around data, it would be a little bit more. I think, okay, maybe we should call it compliance, security, ethic, don't know, but what is the right term? But also on production, like how we would make sure that the data that model is getting wouldn't exploit model in a way that we don't want. So I think again, like, it's nothing new in software. Of course, we in traditional software, but I think that we'll see a development on this end as well. So I think GitLab is calling DevSecOps. Yeah, so maybe we'll be calling LM SecOps, or okay, I'm not good in names, but but I think that there is that this area will be growing once more of those models, or once we have more and more companies applying those models on for production use cases. This will be important as well.
Piotr, in the article MLOps is an extension of DevOps, not a fork. You discuss the definitions of experiment tracking, model versioning, and ML metadata store components. What are your current thoughts on this?
I think that what Piotr spoke about is that model registry, in a sense, is just another way of packaging software, right? So we already have software package repositories out there. For example, Nexus, very popular open source one, right? So model registry, in a sense, is the same thing, and it's just for models, so deployables of models, and they can be packaged also in different ways. It can be either a Docker container that already contains the full deployable or similar, but it is also very close to software engineering world. So if you can provide such a package that can be deployed with a specific, I don't know, command, or it can be wrapped in a specific way in already existing software, it's just another type of package registry, kind of, right? I think that's what you were thinking about, Piotr, or do you have some additional thoughts around it?
For quite some time, I thought that model registry component shouldn't be equal to model packaging. Like, there are two different concepts and different jobs to be done. And model registry should be very flexible when it comes to model package formats. And I think this need is now even more visible because of the dependencies of external systems, external versions. It is okay for some use cases. It can be just a Docker, right? And it is standalone, doesn't need to communicate with external world, easy. But with multimodal use cases, this is usually a set of versions that you want to somehow fix. That, okay, this is tested when we are using this version of this model, this set of agents, etc., etc. So I think that we will see, like we have in Python, requirements.txt file where we have where easy way to control all the dependencies, but within the single Python service. We will have similar things for large language models as well, and a model registry for me it is more about having having a place where I understand what are the models I have. I'm able to reproduce them. I have everything that is needed to deploy it. But what deployment means in this context is not necessarily deploying a Docker image somewhere, right? It can be purely virtual. Like, it is how I am going to configure a set of APIs and points. It can be also thought as a deployment. So, yeah. So when it comes to software deployment, I have never seen model registry as a component that should do that, but rather a registry that is more passive, that keeps all the metadata needed for me to understand what this model is about, what are the dependencies, what is the story of this model, how it was created, things like that. That's why for me, experiment tracker and model registry were always quite close.
Mm-hmm. But so would you see also models that are not ready for even considering for deployment also
Absolutely.
something to be kept in the model registry?
Absolutely.
Hmm.
We just need, I think it is just a matter of labeling it. Maybe a tag or so, stage. But definitely it makes sense. Yeah, to have a place where you can store a concept of a model, but this concept got recently broader than it used to be.
With layoffs happening this year, there is a general trend of people getting more efficient. In your opinion, does it affect the composition of ML teams? Is ops going to be centralized even more? Do you still believe that MLOps teams should consist of DevOps engineers, backend software engineers, and data scientists, ML researchers?
It is still valid, but I just wanted to say that I don't see team composition so much related to layoffs. But okay, it is all about efficiency. So if you have pure pure research ML team in an organization, they cannot be. They are usually not able to do POCs forever, and it is the pressure is higher to cut such forever POC type of projects and tips. So you're ending up rather with, but you wouldn't be cutting things that are generating revenue or profitable for your business. So I think that this is a force that push. Yeah, I was always a bigger believer in decentralized ML teams, teams that are very close to problems, business problems that are within particular business units. But at the same time, it is not necessarily true when we are talking about ML platform team, because platform teams are there to not to repeat the same thing in many times within one organization, to share processes and infra. So I think it is, so we have, when it comes to efficiency, there is another force that would move, yeah, that would encourage companies to share what can be shared. So I think when it comes to ML teams, I see them rather getting closer to business units, because the era of a lot of POCs, I think it is hard. Like, yeah, it would be more challenging.
Do you agree that there is no connection between LLMs and layoffs in the industry?
I think that it's partially true. Of course, everyone is laying off because of the startup landscape trend that we see, right? So the companies becoming more efficient in this hard economic situation. But again, the rise of LLMs, I do believe that it impacted who got laid off quite a lot, because, for example, of course, we are talking about LLM use cases that LLMs can solve, and use cases that let's call them now classic machine learning models can solve, right? And they will always remain like use cases that require very high throughput in the very fast speeds, like ranking systems and similar. But then we have the entire field of NLP, right? So I think that classic NLP is dead, right? Most likely. Most of the use cases will be solved by LLMs. And there are a lot of researchers, I think, and data scientists who tried to solve NLP use cases for companies, and LLMs came, and that's it. You don't need like classical NLP models almost anymore, right? Because LLMs can solve most of it, and they are getting cheaper. Like even the weakest LLMs, like not talking about GPT-4, like GPT 3.5 is good enough and better at solving these problems than classic NLP models, right? So I think that had a big impact also on who got laid off. I think these problems are now a lot less researchy, because engineers can solve them, right? Engineers can start plugging in LLMs with documents and summarizing these documents and or extracting named entities from a documents. You don't need a data scientist there anymore. As well, we also spoke, I remember in one of our podcast episodes about how we believe data scientists have to evolve. So either they become more of a business BI analysts, so closer to analytics, or becoming machine learning engineers. And I still think that is the case. But then probably we'll have also engineers who would be just engineers and not labeled machine learning engineers who can also solve machine learning related problems.
So, do you see like a case where, let's say, there is NLP problem that is very important for production use case? It is on production. It was built by data scientists and is operated. It is definitely would try to figure out whether it's what you can do with large language models to replace it or improve it. But I would assume that the task would be given in such case, like to improve it. There is testing around it to data scientists first. That's why I. But okay, so it is one
I
case.
agree. Yeah.
Second case, yes, like it is not on production. They are playing. They are trying to figure out what they can get. It is still kind of POC research project. This, I think, it is very likely to be killed. Like if they spend half a year or a year already, and results are not so great. And imagine that in 2 weeks there is some software engineer intern who came up with something equally or more promising. This is very tempting to kill this POC traditional NLP project. But I, like in those two examples, I think that the main thing is whether it's on production or not, whether it's used or not.
It really depends on what you label production, right? If you're requiring these instant answers from your model, then of course not. But there are just use cases where you summarize documents, you do some sentiment analysis, you extract things from text, like named entities, etc. So these are very legit production use cases. I think that a lot of companies rely on to optimize their work day to day. It's not user facing; it's usually internal, and maybe cutting other costs significantly. But these are, in my mind, production use cases, and I do believe that companies have spent a lot of money on data scientists who were building these solutions for the companies to become more efficient in their day-to-day operations. At least that, and I know that it's the case. So some of them actually are like some of these remain in POC forever. I guess now it has come to an end because no one will be POCing for a lot of money just to not get any result. Right?
I think, Aurimas, that maybe what you are saying is something that we will see, but for me, it was hard to believe that it would happen for production use cases so quickly. That's you have a traditional model that's what works. You're dismissing data science team, or part of the data science team, because you hope you will be able to do the same or better with LM. It may, I think, eventually we can see this trend. But when we are discussing the layoffs this year, I think.
So you're saying it's too early, basically.
Yes, I am talking. Maybe there are cases like that, but I think that the if we try to assign weights, the weights would be around global economics needs about efficiency and cut the POC projects that are more around trying to find an edge, but not proven to be delivering value. And And I don't have data, but I would be interested to see maybe some people can add some points in the comments to see the statistics around layoffs and compare it how it is versus software engineering, for instance, right? But we can say again, and I think here it can be actually here. I would believe that LMs had a bigger impact. That's we with Copilot. I started using it recently myself for Rusted Engineer, X Engineer. It's very useful because you don't need to remember the methods and you spend less time on searching through docs. But I think here I can imagine that you can run some projects faster with a smaller team of more seniorish engineers than a regular composition where you have some seniors, some juniors. I think junior engineers they are they could be dismissed more often because of large language models, but don't have data to prove it, but just a gut feeling.
Are ML and Dev or DevOps platform teams more aligned now than they were a year ago?
To be honest, I don't see it ever emerging. Like, it's my opinion, because there's just a limit of people you can have in a single team, and usually you anyway split even the software platform teams. If you grow big enough as a company, usually they are composed of multiple pieces, so you can have a networking team, a application deployment team, maybe another platform team that only bakes libraries, and I don't see how you could connect machine learning to one of these, like, because it's just too big of an area. When it comes to large language models, I think that they can be relatively easily deployed using regular software deployment patterns. It is a bit different because it is, in some cases, distributed deployment. So usually that's not what you have in regular software. But these are technical problems, like very complicated technical problems, and require, I think, very deep software architecture understanding to do it correctly, right? So maybe some connection here can be established, like maybe these models could be deployed by software platforms, while their training and evaluation would happen in regular machine learning platforms.
I think it is maybe it is too easy to not too early to see already, like that it is moving this direction or another, but I think they will be getting closer and closer, because the testing of such models, or maybe we should say model set of models working together. Today it is not so obvious how to do it properly. Like, we have different techniques, but I don't consider this problem as solved. But I definitely see that it will be part of the. It already is to some extent, but it was done in a phases where you could kind of independently test models, and then independently from software release. Maybe you can do it similarly, but more interconnected it is, more end-to-end issue you need to test it. So I think that we'll see this as a force that would push those teams to at least work closer. The same goes with security.
By the way, just to add, I do observe, and I've always observed, that machine learning platform teams are very close to software platform teams, because basically you're building on the same platform. It's not a separate platform, it's the base that is shared. So basically the collaboration patterns between the machine learning platform team and a software platform team with, let's say, core platform team are completely the same. You're using the same infrastructure, building on the same core kind of capabilities. It's not far away. Even the release cycle and testing, A/B testing cycle is basically built in the same system, usually.
Do you think the trend of integrating security into the developer's toolkit, as seen with Snyk, will eventually reach ML builders?
Definitely, it makes sense. Because you cannot test everything. You wouldn't catch everything in end-to-end tests. That's why it's super important that people who are, developing small details are aware. So it is very valid. But on the other hand, and I believe it has to be done together. But I really believe that with the incoming regulations, companies will need to be able to prove that they at least try to do something, diligently about security, and saying that, like our engineers or our ML engineers were on the workshop and know the practices wouldn't be enough. They would need to have some level of proof, especially in more regulated spaces. So I think, yes, it is needed in software space. It was always needed. It was always good when engineers knew the basic practices, but still the need of doing audits, doing tests on a higher level, end to end, and being able to prove that it was done. I think we'll see more of that, and that's why I think growing role of the, don't know what would be the called, what was this job title, this function would be called, but something around security and compliance will enter more strongly to the picture of ML platform team. I'm quite sure about that.
Tekton reports a rise in central ML platform teams, especially at large orgs, whereas Clormel finds 58% of ML professionals using a single MLOps tool, with 92% preferring one solution for everything. What is your perspective?
I think that the growing percentage of companies above 250 employees or 1,000 employees having internal ML platform teams shows that there is a need of unification, simplification, tech stack for ML teams that would be implementing particular ML use cases. Not surprising. At the same time, looking at the Clear ML report saying that 58% of people use one ML platform, MLOps platform or tool, and 92% would like to use one platform for everything. I think it is especially the second part that 92 would like to use. Me too. It's not surprising. That's if I could use one, I wouldn't need ML platform team. And why I should have a team if I could have a tool that does everything, right? It is it is a better way to solve this particular need of unification tech stack. But I would give you another example, more traditional. I would also like to use one content sharing system, not Notion, Google Drive, and Slack, and email. I would like to have one tool, but the question is how likely it is that I will have a one tool that works for my setup, for my infrastructure, for my use cases out of the box, and won't clutter me with things that I don't need. And I think it is the reason why we have a growing number of internal ML platform teams. It is very hard. I don't believe it is really doable to create one market standard ML platform team that will work for everybody in such a growing space, fast growing space like ML. Or those requirements, the methods are changing. It is very hard. Bigger system you have, harder is it to change it. So yeah, I think I think that data scientists and companies would like to have that the goal is I don't want to care about tech stack for ML. I just want to solve my ML use cases quickly in a repeatable, under control, secure way that perform. More obstacles I can remove, the better.
So I've seen one. I have participated in building of one. It was based on AWS SageMaker. So yes, AWS SageMaker provides a bunch of capabilities, but unfortunately, it's good for starting out, I think, because everything is in a single place. But once you start moving to production, you start seeing that you're lacking certain capabilities. And I think that, for example, what also Tecton is saying, that they are catering really to very heavy production use cases, right? So they are spending a lot of time in one specific component that is crucial for deploying machine learning to production, which is very efficient feature organization, creation, storage, and then delivery. Because it's not easy to create such a system that would give you fast enough responses, so low enough latency with high accuracy, and then you would be able to transform features on the fly with very flexible and UX friendly API, right? So it takes big team to just create this one piece of MLOps stack that would be really ready for enterprise and production use cases. I don't think that any end-to-end platform is, to be honest, including SageMaker. Again,
Guys, would you say that SageMaker is end-to-end platform? That
it
is
is
a platform or set of components? I understand.
like with SageMaker Studio, they kind of already combine quite well the components under a single, let's say, abstraction, where you don't need to think of everything that much, like as a separate components. You still have a separate pipelines SDK, for example, that you need to be able to use. But when exploring the data, like visualizing the pipelines, seeing the metadata, it's in a single place. You can log in to a single place and you can control everything from there. So you don't care that much about elements. But they lack quality. Each of them lack quality to some extent.
As 2023 comes to an end, what's your stance on the single components versus end-to-end platform ML debate?
So in my mind, nothing much has changed, to be honest. Like we entered the 2023 with a split that we currently have in the MLOps, let's say, tool stack. So we have experiment tracking systems, we have feature stores, we have pipelining, authoring and orchestration tools, deployment tools, and observability systems. Because we already had observability systems at 2022, I think. And I think that we leave 2023 with the same split, nothing yet merged. So my prediction is that eventually some of these will merge into a single kind of capability, and there will emerge a new standard of what combinations are the best fit, but we are not there yet. No one is merging extensively. I think that observability and experiment tracking is something that is relatively close, like being able to analyze both how you create the models and how then they perform in production in the single place. It makes full sense, because you have the models that you will be deploying. You don't necessarily need to care about the deployment itself, because it is a very, very big area that requires a lot of kind of deep thought around it. But once the models are deployed, you can very easily collect the feedback metrics around how we are performing to the same system and display it in the same system, basically. And it would allow data scientists to really, or machine learning engineers, to really not leave one system that much, because you would be able to see it in a single place. I think that's a good one.
When it comes to components that should be merged, of course, I'm focused more on experiment tracking and adjacent components, and I fully agree with Aurimas on monitoring, especially when you think about large language models, where execution is a big part of development process as well, and testing. So I think it makes sense to look at the model behavior on development stage from similar lenses as you see the very same model operating on production. So I think it makes sense. Don't know when the space will get stabilized enough to really figure out how to merge it properly. I think we will. Okay, I think there is another potentially space, but I think I see it as a part of experiment tracker job that was used not to be so visible, but in fact it was the job.
What is the difference between LLMOps and MLOps? What do you think are the core jobs to be done when operationalizing LLMs?
I guess similarities are only there when you're thinking about fine-tuning large language models, right? So the life cycle the model's life cycle in a regular MLOps processes chain is a lot smaller. It's the very end of it, right? So fine-tuning the model to fit your use cases, and then when you think about it, it's very similar to any other machine learning development, machine learning model development. So any other deep learning model, actually. So you fine-tune it, and then you just analyze the results.
In the context of LLMs, what aspects of ops have become 10 times more critical than they used to be?
Like, I think it's just different how you treat them after you have a model. Like, so there's simply another piece of the pipeline you need to do, which is prompt engineering and prompt tuning. And
I think that monitoring would be the okay. It's not new. It's not new, but because you have way less control, because it's more complex, more black boxish, more depends on more systems. I think understanding how it behaves, it is harder, more important versus traditional ML. Easier to accomplish something bigger, but also easier to fail.
yeah, and also but it's still like monitoring, so it's nothing new. Like evaluation is also nothing new, but in the case of large language models, we still don't have some general methods of evaluating these models that we could use, right? Nothing has still been created. Nothing has yet been created. So regular metrics do not fit evaluation. People are using other large language models to kind of evaluate outputs of another large language model, which is now, I think, considered as the best way of evaluating large language models. So it's still not something new, right? It's still model evaluation, but just the methods that are needed there are lacking. We don't have it.
They have a concept of, okay, maybe it's called differently, but major or main job to be done and minor, something like that. Yeah, there is evaluation, right? And we have then jobs to be done that are way more precise. So I think from main perspective, the set of jobs to be done quite likely is very much similar. But if we go deeper, how you do particular thing, the differences will be in details, like evaluation.
What major sub-problems in LLMs remain unsolved as we transition into 2024?
Metrics that we can trust to say that this is the output of large language model that we would expect and find accurate enough for our use case or for our expectation, because you might have you might have an input, a set of like evaluation set of inputs and outputs that would be ideal for you, right? But it's not so easy to compare text to your preferred text, right? the output text to your preferred output text. There are no metrics for that you can 100% rely on, and that's why we are kind of using these kinds of methods, like using other LLMs to evaluate it, right? And then LLM can say that this output. So you can describe to LLM how you want to grade your output. So you expect this and this, and this is the grade from 1 to 5, and each of the grades represents some specific values that you would expect from an answer, right? But this is also super, like, it's just weird, I would say, but it works, right? I don't know. So maybe some breakthrough maybe in context comparison between multiple text pieces. Or maybe one more. So we talked about like new things that are maybe a little bit specific to LLMs, but not necessarily like they were there before, but the rise of vector databases, and mainly because of this pattern that is very popular now, retrieval augmented generation, and basically keeping memory outside of large language model itself, so that you can store some embedded data in external vector databases, and then you can retrieve that on the fly while the LLM is kind of actually not by LLM itself, but providing some additional context to your prompt via a prompt template, so that context can be used by LLM to answer specific questions, because the context window available in LLMs is both costly and not long enough to take in like the entire textbook for context, right? But of course, we are also moving in the direction of solving this, either by directly plugging in maybe.
Can you do it by agent?
So usually I think that's how it would look like, right? You have an agent that extracts needed context. You can say that it's just your application that extracts that context, right? But and we already, I think, have solutions for that, like that agents decide on how to extract the context the question needs from an external database and inputs it into your
I'm thinking whether agent cannot communicate. What would happen if agent communicated in a kind of more compressed vector way, not by text, right? Because why use natural language if you can send back vector and
but communicates to what?
to model?
You mean without needing to? Because anyway, like even if you provide a prompt, eventually it's vectorized.
Yeah, that's exactly. So I'm thinking, why not to use agent that wouldn't be speaking natural language, but just would be speaking in the vector space, so to speak. Maybe it will work out of the box.
But that's what we almost do, right? Because you still need to have a question or some context that needs answering provided by human. And that's what we actually do in the retrieval augmented generation systems. We embed it into some vector space and then search vectors in the vector database. And we only translate it to text because we need it as part of a prompt that would be sent to. So in my mind, it's still communication in vectors, just few extra steps.
Yes.
What use cases do you believe are not meant to be solved by LLMs in 2024?
High throughput recommender systems. You'll not get anywhere close to the throughput you need, I think, in the next year. Maybe at some point in time, but doubtful. Maybe we'll need something different that is not LLM, I think, to be able to solve these kinds of problems. In
throughput, latency, I think you're right. We will be we'll be exploring capabilities, like what are the limits if we can wait. And then once we plateau on that, I think we'll be trying to get it faster and faster. So quite likely there is still a lot to explore when it comes to limits how smart they can get.
And I think that 2024, maybe these, like specifically these use cases that are latency critical, might be the only ones that will not be solved by the end of 2024 or in 2025. I don't know. But I think we are talking now. We are now talking a lot about security and how to make LLM secure. I think it will be solved by the end of 2024. Like at least there will. Actually, I see a new. Yeah, maybe it could be called a new area of MLOps that it's being created. So guardrails, basically. So some proxies that you put before and after the LLM, right? So that you can make sure that anything that goes in there can have some extra security gates, especially when it comes to enterprises. So, for example, now I heard of cases where people will be using LLMs if they are not restricted to. So, for example, if you're in a bank and you have access to sensitive data, no one, no one kind of restricts you from accidentally copying some of that and then using it for in the public LLM API, right? But I think where we will converge, at least in the next year, you'll have companies that will provide these firewalls in between, maybe even the public LLM, that you can plug in into your enterprise, even a bank, for example, and then allow all of your users going through this specific endpoint instead of going to these public LLMs directly. And I think we'll solve security next year. I think most of the cases that are now kind of labeled as not too restrictive security-wise for LLMs will be not there anymore. So maybe only latency, and maybe for some cases, of course, when you need 99% accuracy, maybe also not, but there are not that many of these, right?
I think that with agent architecture, I think that we'll be exploring this a lot. It would be harder to say, like they will be so much more and more connected, so it would be hard to say whether it's solved by LM or not. Maybe it is solved by LM with classical model next to it. How do you count that? So definitely, okay. So when the latency is important, quite likely technically there is no way. I was thinking about very specific problems where data is highly confidential, regulated, but in this case you can go with open source models. So it doesn't count then.
Much to the frustration of ML researchers, it appears that still the best way to move forward is to put more layers and more neurons. What is your stance on this?
I'm wondering how far we can continue going with GPT and basically just transformer architecture. I think something new will have to be created for a bigger leap, or a combination of a lot of these into a single kind of organism.
I think it will be done at the same time. Like the hardware is getting more powerful. I don't know how fast it is growing, but it was growing. It used to grow exponentially. Don't know what is the pace currently, but still growing. So if you have a safe bet that's putting more nodes, putting more electricity leads to better results, I think this will be explored. Maybe not everybody, not every team in the world can do that, but I think we won't wait. We will be putting more and more and trying, like to discover the limits. At the same time, I think we have this latency challenges, scale challenges, cost challenges, and it is all about like they can be solved by doing something smarter when it comes to architecture of those networks. So I think on one hand we'll be discovering capabilities, and we won't be thinking about too much electricity. No, we will go full force to understand what is possible. I'm quite sure on that. But on the other hand, you have movements, how we can compress it, how we can get similar performance, but 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 maybe use less, less power, less resources. So I think that it will be happening in parallel, and once we have a better architecture, quite likely we'll try to use it with similar or bigger scale that the models we have today. Just understands, what on top we can get.
Yeah, because for example, OpenAI in their press releases, not press releases, even conferences, they are kind of projecting AGI in 5 years or something, I think. So I'm wondering if AGI will be, I don't think it will be transformer based. Probably we'll have to find something new, right? To make it happen. Because I'm wondering what are the limits of this current approach.
I remember I remember Wojtek. Wojtek Zaremba, one of my discussion with Wojtek, it was 8 years ago or so, one of the co-founders of OpenAI. At that time, he believed that AGI it's just scale. It is, so we can do it with, like, okay, maybe I misunderstood him, but I remember that it was going in the line that with this architecture we can make it, but it is just scale. Like, don't know whether it's this amount of this amount, but
Okay.
just matter of scale.
What do you foresee happening in 2024?
I think development around, let's call it prompt authoring. So we have LangChain, but I've heard a couple of times that it's not necessarily okay. It's doing a great job, but it's not necessarily the ultimate data model how to represent prompts, agents. So I expect to see some development here as well, especially if we okay, it's easy to adjust. Getting back to this concept of having somewhere this external knowledge vectorized, so this will need to work together. So I think, we see something here. I am curious, but don't know how to do it. Having experience as a user of ChatGPT or other tools that are using it under the hood, the very first result you get is usually quite good, but it is not necessarily easy to iterate with it in a kind of stable way. I just want to replace maybe those two words, and I'm getting something reorganized too much from what I needed. I think, I don't know how to do it, but something that would keep this more stable and allow for tiny changes, local changes. But I'm talking here from user perspective. It's something that I would like to see.
I think that so my additional thought is that maybe some new players will start from LLMs in specific areas. So maybe it could be, I don't know, a framework of training. So simple, similar to LangChain, right? A framework to train LLMs, and then we could expand to more use cases. So maybe it's also a niche where you can start your business, but then expand somewhere else. Because I don't think that just sticking to LLMs makes sense, because then you're, losing a lot of market. It's not a dumb idea, but only I think it's still viable only for the companies that only do LLMs. Because if you're a company and you need a tool, then you will also need then two tools, right? One for something for classical ML, and then one separate one for large language models. And I don't think that companies that are doing classical ML are not in a good place to introduce LLM support. as a addition to the already existing.
The ML Platform Podcast was brought to you by Neptune AI. If you'd like to learn more about ML platforms and MLOps, check our blog at neptune.ai/blog. Follow us on LinkedIn or subscribe to our YouTube channel. Also, check out how we help teams solve MLOps challenges with our experiment tracking at neptune.ai. To get notified of future episodes, follow us wherever you get your podcasts. Thanks for listening and see you next time.